The next constraint we're going to talk about is the notion of cache or caching of data. Now, if you've done web development before, caching of data may seem like an obvious sort of idea. Output caching in ASP.NET MVC, or even web forms, or creating smart caches with things like session state. And so the constraint of cache really has to do with dealing with returning the same object when an individual request is made for it, so that there isn't extra work being pushed onto the system for every request. If every time we come in and ask for the food called butter, we should be returning that butter without having to go back to the data store. Currently, what we've been doing in our implementation is actually loading data from the database each and every time. We haven't really supported that notion of cache. But cache also implies some other things. So when we make a typical request, cache also implies that we're going to use some mechanic to version the object that was retrieved from the server. Not just the ID, but also the version of that, so that the cache can be useful. And in this way, when you're supporting cache, you're typically going to support it by including an ETag header in the result. And an ETag is a magic string that says you asked for the butter food, and this ETag represents this one food as it exists at the time it was retrieved from the server. The benefit here is that later when you make a subsequent request, you're going to include the ETag in the header to tell the server, hey, if you already have this version, tell me because I have the ETag, therefore you don't actually have to return it to me. And in this way I can do very efficient tests by going to the server and testing to see whether a particular resource has changed. Now, in the case of something like our food API, where the data is fairly static, that's not as important. But you could imagine in a diary app, where you may be getting the diary and want to know that that diary hasn't changed. This can be very useful, especially when different devices and browsers and sometimes even users are going after the same data and making changes to that same data. And so the idea of cache can very easily layer itself on top of this notion of concurrency as well. If the ETag sent in the subsequent requests is there, typically a 304 is returned without the body of the message, and that's the message back to the client saying, you already have the most recent copy of this object, obviously, because you gave me the ETag, so I'm not going to bother sending it back to you. So what do ETags look like? They're a unique key for a particular version of a resource. They're returned in the header and often used for calls later back to the server, also in the header. So if I go ahead and make a request, when the request is returned to me, including the content and the body, it's going to include an ETag header. This ETag is just, again, a magic number and is going to include a prefix of w/ if it is a weak ETag. The difference between a weak and a strong ETag is how persistent that number is. If this is the same version number as it's going to exist for days or weeks at a time, it'd be what's considered a strong ETag, and it won't include this w/. If it does include the w/, it means it's weak, and this version is useful, but only useful for a shorter amount of time. So now as the client has retrieved this ETag, they can use it on subsequent requests. Usually with get and delete, you're going to use the if none match header value. So here if we do a get to nutrition foods, you can see this if none match using that same ETag. This is going to tell the server, hey, if you have a newer version of this get, return it to me. Otherwise, return a 304 to tell me you have the most current version of this. And in this case, it's going to tell us that the result on the server is not modified because our ETag matches what we have on the server. For put and patch, this is different. Whereas with the get and delete, we were using if not match, here we're going to use if match. So we're going to say, make this modification only if the ETag matches this if match clause. And if the if match fails, it's going to return a 412 or precondition failed. This is just the semantic of how ETags work. So let's show you how to implement this in Web API.